Hello and welcome to this video. In this video, we are going to start looking at generators in Python. So in so far we have been seeing about iterators when we have learned about concepts like what are iterators, what are iterables, what is dunder iter method, what is dunder get next, what is dunder get item method, what is dunder next method. And we had also seen an example where we had used all these pieces in just one code and then how it works all together. Now we are moving to generators, and generators are not very different from iterators. That's why they are included in the same playlist. So let's see what are we going to look at in generators. So here on the screen you would see two questions and answers for them respectively. So let's try to look at and try to form a base before we move from here. So in generators, we have generator functions. So the first question which says, okay, what are generator functions? Generator functions are any functions which have yield keyword in its body. So any function that has yield keyword in its body, it's a generator function. Okay, what it does, I'm going to explain it in baby steps. I'm going to take it low and slow, but just try to understand whatever you can from this answers from this statement, from these statements. Just try to at least grasp that, okay, any function that has yield keyword in its body is going to be a generator function. Okay, what is a generator object? Very first thing, that if you invoke a generator function returns you a generator object, and that generator object also implements the iterator interface. Well, if you recall, any iterator, because when we used to extract the iterator out of an iterable, that iterator used to contain that iterator interface, due to which we were able to perform loops and iterations and stuff, right, like that. But here what we are saying is generator object that is returned by generator function also implements the iterator interface, which means you should be able to perform loops using that iterator interface because that generator object has. So okay, that's enough for now, and let's try to move into some example, move and see. Some examples. This is a very basic, very simple example that I can show at the moment. Uh, this is a function def gen func. I've just prepended it with gen so that you understand, okay, this is generator function, but there is no such syntax or no such there is no such convention to follow. But the only thing that will make your function a generator function is having a yield keyword in its body. So how do you write yield? It's like you yield some value. So basically you are yielding one out of this. Just understand, but for now, but we will see how it works. So this is a generator function because it has a yield statement in its body, yield keyword. Now I am actually invoking this function. So normally what happens, you are expected to execute the body of the generator function, body of any function. Once you invoke that function, you think that that function would get executed, but this function returns you a generator object. Though there is no such return statement, mind you, just have a note of it. There is no such return statements, but that function still gives you a generator object. Okay, now because you have a generator object, let me print that generator object and just have a look at it. So if you see, I have printed this generator object G, which says, okay, this is a generator object that points to gen func. So this is a point. This is an object G, which is constructed out of this generator function. So once you execute, you get that G. But and because G also implements the iterator interface. If you don't believe me, let me show that to you. I'm printing this to see what is contained in the generator object. So we are looking for two functions basically, which is dunder next and dunder iter, just to make sure that it complies with the iterator interface. So we have this dunder iter method that's there. And do we have dunder next? We should be having it. Yeah, here it is. So we have dunder next and dunder iter, and that's the reason why we are able to loop over it. And that's the thing. So whenever you get a generator object out of a generator function, you can perform looping. But how does that work? How you it's understandable that okay, whatever the object that you're getting, it implements an iterator interface. But how does yield gets executed and how it works? So basically what happens, you can think of a generator object which keeps track of your function. Once you try to get the item of your generator object, so which item I'm talking about, all those items which are yielded here. So okay, before that, let's take what is the output, what is the current output that this program prints. Ignore this. It is printing whenever I'm trying to loop, it just prints 1. Okay, let me separate that if that's confusing. So anything, yeah, so here it is. Here is the output of our for loop, and it just prints 1. Why does it print 1? Because we are yielding only 1. To make it more clear, you can yield 2, you can yield 3. So now let's try to loop. So it prints 1, 2, 3, which means every iteration of your for loop, in every iteration of your for loop, your val is being assigned with the value that is getting yielded here. Every each, for example, in first iteration, val will hold the value 1. For second iteration, val will hold the value 2. For third iteration, it will hold the value 3. That's why we are seeing these printf statements. Now that's clear till here, but let's try to understand how is that happening. Why is that every yield is how is that yield coming in at every iteration of the for loop? So what happens when you try to execute your for loop, your iterator object, your generator object particularly, uh, it keeps track of your function, because your generator object is actually pointing to your gen function. It actually keeps track of your function. So your function, once you start looping, your function actually gets executed at that point. So which means your function is not executed at here. Let me make a note. The function, or specifically the generator function, is not executed here. uh, Actually your function starts execution when you run your for loop. So when you run your for loop, at every iteration, generator object stops at the first yield statement. So once your for loop runs for the first iteration, generator object will try to find the first yield statement in the function body, and it will find 1, and it will stop there. And whatever yield statement is yielding, which is it's yielding 1 here, that value will be assigned to your val in the for loop, and you can print it, and we are printing it, and that's why we are seeing. But when for loop continues with the next iteration, the the generator object resumes where it had stopped earlier in the generator function body, and then it will pause at the next yield statement. And where is the next yield statement? Just right after the first one, and it yields value 2, and 2 gets assigned to your value val, and then val gets printed, and that's why we see 2 here. And that is where the generator object pauses. It actually takes a pause here, and then once your iteration comes again in for loop, it it resumes the execution of your generator function body, and then it comes and stops here at yield 3, and that's why we see yield similarly. But what happens right after that? Once the for loop comes and tries to execute again, generator object will begin, but actually the function is returning from here, right? We don't have anything after that, which means function ends, and that is the time when the stop iteration signal or an exception is raised, and it is handled by your for loop behind the curtains. You don't see it, you just tried it. You're not aware about stop iteration being handled in the background, but that happens. And your function, your for loop terminates elegantly. You are not aware about it, but that's how it happens. I hope it was you were able to follow. It's pretty simple if you look at generator object as another kind of or another variation of an iterator. It's not an iterator. I don't want to say that okay, iterator is generator, but I just want to say that treat generator object as a generator object which implements the iterator interface, and because it implements that iterator interface, you're able to perform loops. Okay, now let's move on to next example, and we are going to see how actually that body gets executed. So let me have another generator function here. What we are having is, in this generator function, we have this for loop which runs from 0 to 9. 10 is excluded, and then we are printing, we are yielding every time every integer from 0 to 9, and we have these print statements in between, and we are returning hello. This is really important for us to understand how actually generator object progresses, how it progresses with yield statements. As I said, that it stops at one yield and then resumes and then stops at another yield statement, and finally when return happens, a stop iteration is raised, and that's where your for loop execution stops. So we have our generator object here, and then we are actually performing the similar for loop. And now, if you have seen my last video, last video, where I have explained that behind the for loop that you write, when you get the iterator and you try to loop over the iterator, behind the curtains, there is a for loop machinery that works. It actually invokes the next, and that calls your dunder next method in your iterator, and that dunder next method, once it has finished, it raises the stop iteration, and then your for loop machinery catches that exception and then terminates elegantly. That happens. So basically, you have this for loop, uh, for loop, and then this for loop under the hood calls that for loop machinery, which we saw, which we actually implemented using a while loop. This for loop machinery that we implemented using a while loop, where we explicitly invoked that next statement. But that's okay for now if you don't understand. But for now, if you haven't watched that video, I would recommend go and watch it so that you understand it better. But if you haven't seen that video, just think that for loop machinery is another piece of code that gets executed that to make your for loop work that you have written. It's very pretty. It's the for loop that you have written is pretty clean. You don't have to worry about what is going behind the scenes. But behind the scenes, there is a machinery that runs, and it invokes your next dunder next method, which is because you are looping over this go generator object or any iterator object. As I have said, that they implement dunder next and dunder next and dunder iter methods. So what that for loop machinery does, it invokes that dunder next method explicitly, and once that next method raises that exception, which means for loop machinery invokes your dunder next. So what happens? For loop machinery runs and invokes this next method, and this next method, dunder next method, raises stop iteration, and stop iteration is handled by your for loop machinery, and back up your for loop terminates. That happens. Uh, the for loop invokes for loop machinery. For loop machinery invokes the next, and every time your next is invoked, it fetches the item, and that item is assigned to your for loop looping variable, and that's how you continue with iterations in your for loop. But once that for loop machinery invokes next, and this next has returned, instead of returning the next item, it has returned an exception, which is it has raised an exception, not returned. It has raised an exception which is specifically stop iteration, and at that point your for loop machinery terminates, and so is your for loop. So that's what happens behind the curtains. So let's now let's see this example. Probably things will get clearer. So what we are doing is, we have this iterator object, and we are trying to loop. The only difference is that from the the only difference from the previous example is that we have these print statements in between, and we are just looping. Instead of writing yield statement multiple times, I can actually reduce it. Let me not print it for so many number of times, maybe print it 0 1 2 3 4 times, for 0 for 0 1 for 2 for 3 4 times. It will print your it will, before yielding, it will always print before printing, before, let me call it as yielding. And then we finally return. This statement also gets printed, and then, yeah, okay, let's run it. Okay, now let's try to analyze this example, this output. So what happens? Okay, actually, go, which is generator. It is just, so I'll tell you why I have written that. I have written this statement just to make sure that whatever gets printed, I mean, whatever the text we are printing is coming after this statement, just to make you clear that our function doesn't get executed at this point. Just generator func, it doesn't get executed at this point. It gets executed only when you start looping. So that's the thing. That's what I have told you. Your generator object keeps track of your generator function body once you start looping. So it actually executes once you start executing your for loop, your generator function, generator object starts the execution of your generator function. So now let me print. Yeah, so you see here, right? Generator object is created. This is printed after the generator object is created, which means here we didn't execute anything. Nothing is printed at before this. This is the first statement to get printed, which means we have not executed our function at this point. But once we start looping, what happens? For the first loop, for the first iteration, right? Your generator object will try to execute your generator function. What it will encounter? It will encounter this first print statement, and that's what it is printing here. Okay. As I said, it will always pause on a yield statement. It has not encountered that yet. Then generator object will find, okay, this is your for loop, and then it will start looping. And this, in the first iteration of this for loop, it will first encounter before yielding. So that's where it is printing before yielding, because this is the first iteration. I's value is 0, and now it has finally encountered the first yield statement, and that's where it will pause. It will yield it, and it will pause. It yielded, and that's why this 0 is coming from this print before yielding. Once it yields, that, as I said, it yields, and your dunder next method returns that value, whatever is yielded, back up to your for through via the for loop machinery to your for loop, and it gets assigned to your looping variable, and your looping variable, we are printing 0 here. Right now, once the for loop goes into next iteration, it tries to print. Your generator object parallelly continues with the generator function body, and because it had stopped in this for loop, it will continue and it will resume with the execution of this for loop statement, and then it will encounter before yielding again. And this time, because this is the second iteration, this i's value will be 1, and that's where we are seeing before yielding 1. And then it will encounter the second yield statement, which is 1. It is yielding 1, and then that yield will travel back up to your for statement. G will be assigned with 1, and that's where we are printing G. And this is how this statement is coming from here. Same thing will happen for 2. Same thing will happen for 3. But after 3, once your for loop here continues, your generator object will search for next yield statement. It will try, because already we have printed 3 statements, 4 values, which is 0 1 2 3. Then this for loop will break. It will come here, it will say print, it will see this, encounter this print statement, and we will finally print this. But it returns, but the next statement says that, okay, it is returning from here. That is where the next statement is going to raise the stop iteration, and that stop iteration will be handled by your for loop behind the scenes, and everything will terminate elegantly. So add this return statement. So that's how it will execute. By the way, I have just kept this return statement explicitly because I'll show you that you can, if in that for loop machinery, you can catch this value. How you can catch it? I have this while loop written here. And let's, instead of executing this for loop, let's try to execute this while loop. So what is this while loop? This while loop is actually your while loop machinery that gets executed. I'm sorry. Yeah. So this is an example of sample while loop for loop machinery that gets executed behind the scenes. But this machinery has been implemented using while loop. So I hope you don't get confused with between for loop while loop. Why is while loop coming here? This you can see as a machinery that runs for your for loop behind the scenes. As I said, this for loop machinery, you can think of it as being implemented using while loop. So once you start looping, uh, as I said, that machinery explicitly invokes your dunder next statement and dunder next method, and that's where this next statement you're seeing. It is always invoking on your go, which is go is your generator object, uh, and it prints it. But let me execute it right now. Okay, you see that now we have printed everything, but instead of using for loop, we have used this while loop machinery. So till here, everything was same. Everything was same till here, except that we see this exception was raised statement. That's because it is coming from this machinery. And when the stop iteration was raised, we are raising this, we are printing this as statement. And whatever was raised as a value, as an error, or you can see that exception uh, statement, this is where we are catching this hello, whatever was returned from your generator function. We are able to catch it here. However, this is like unlikely that you're going to use this because this is something which is implemented by Python by default. Just for information, I told you, most of the times you're just going to invoke your for loop, you're going to write your for loop and use that. And yeah, that's how basic generate functioning of generator happens. If you have any doubts, please post it in the comments. I'll definitely get back to you with responses. I'll try to resolve your doubts. And with that, I'm going to end this video and hope you liked it. If you liked it, please like, share, and subscribe to my channel. And I hope to see you in the next one.